Our next SQL lab will be over subqueries. Subquery is simply a query nested inside another query. Both of these queries will be select statements. If you've done any programming, you've probably worked with nested if statements in which you have an if statement nested in either the true or the false part of an outer if statement. Subqueries are very much like that. Let's define then the two parts of a subquery. You have the outer query, and that outer query is going to return or display the results, just like you've been doing. Nested inside the outer query is the subquery. And what's going to happen is the subquery is going to execute, but it doesn't display the results. It takes those results and passes it back to the outer query, and then the outer query decides, well, what are we going to do with these results? Where can you put a subquery? In a select statement, you may put it in the where clause. You may put it in the having clause. Recall that the having clause is the filter for groups. You may put it in the from clause as if it were a table, right? A select statement could return something that looks like a table. And you can also put it in the select clause in which you're specifying a column to display. When you get a result back from a subquery, there are three ways to do so. One is just a single value. Often this will be with aggregate functions. Another option is multi-valued, and that is just one column, and that one column may return 0 or more rows, often used for joins. And then finally, there's table valued, in which the subquery returns an entire table, many columns, and many rows. And that's often put in the from clause. Here is our first example with a subquery in the where clause. Notice that this is the outer query in the black, and highlighted is the inner query. With the inner query, we want invoice total to be greater than the average. Let's take a look at this in Access. I've modified the invoice table and added some invoice totals so that we can do some queries on that without having to join tables. Here is our query in which the subquery is selecting the average of all records for the invoice total. Here is the subquery, and if I just executed the subquery, you will see it just gets an average of all the results. That value, $84.61, is then going to be used as if it were right here. So it's as if I write select invoice number from invoice, where invoice total is greater than 84.61. That value is returned. The value that this query has is returned to the outer query and then used. And here are the results of that outer query executing and displaying results, and they're both greater than 84.61. Let's take a look, and you'll see that all of the other records are below the average of 84.61. Let's go back and talk about those subquery types again. We mentioned that a subquery might return a single value. So where can you put this? You can put it anywhere an expression is allowed. In this case, this is returning the single value 84.61. So I can put the subquery where this would have been a single value, where invoice total is, and this returns a single value, and it belongs there. Again, you can have a subquery returning a single column. And where are you going to introduce that at? In a place of a list of values. And then finally, we can return many columns and many rows, and that is a table. And you're going to put that in the from clause. Well, you know how to do joins. Here is a query with a join. And we're joining the product and the vendor, where the vendor state is Florida. 3 records are returned. Now, the purpose of showing you this here is that you can do a join in a subquery. You will place the subquery here in the where clause. This is going to return many rows of a single column. I want you to notice that ven code is here. We're using the in keyword, and ven code is here. That's the real secret to writing this, is to make sure that you're matching this to this if what you're doing is trying to do a join using a subquery. This creates the exact same result set as the inner query did. Here is the syntax for when you want to use a subquery in a where clause. So you've got your where, and your test expression is usually, but not always, the field that will be in the join if you're using this for a join. So it's the common field between the two tables. Here is a query that returns the customers without invoices. So we're selecting these fields from customer. Where, well, the customer table doesn't show me whether or not the customer has an invoice. I have to take a look in the invoice table. Notice that this inner query is going to produce everyone that has an invoice. Let's take a look. So I'm going to take the subquery and copy it over and execute just the subquery to see what the result set is. Notice the result set is the list of customers that have had an invoice. I'll open that up and you'll see 1, 11, 12, 14, 18, and 15. They all have invoices. That's the values that were returned. But what we're trying to do is get a list of those that do not have invoices. Notice the not in. So we're selecting the customer codes that are not in this list. You could do the same thing with a left outer join and use is null, but personally, I think this is a little bit more straightforward than doing that. Here is that query that returns the same result set using a left outer join and using the is null. The subquery is easier to write. You have 3 keywords that you can use, some, any, and all within your where clause. And you're going to use this with a comparison operator, such as greater than, less than, or equal to sign. Any and some mean the exact same thing here. So you could use either keyword. All means something different. We'll talk about it. Let's look at all first. So if my expression is X and my comparison operator is greater than, and we use the keyword all, and then you have a list of values that your subquery return. This is going to be equivalent to saying, well, X is greater than 2. Because X has to be greater than, it's going to take the maximum in this list, and 2 is the maximum. So this is equivalent to X is greater than 2. Likewise here, since we're doing less than, I'm going to take the lowest number. This is equivalent to X is less than 1. I've never really used it much for equality, but this is the equivalent expression. And here, this means the not equal to. X is not equal to anything here. It's kind of like a not in. I would say these are the 2 most common. So let's look at an example of a query that uses the all keyword. The inner query is selecting the price from product with a certain vendor. And we want to have the product price. Notice product price is here. I want to emphasize that. And product price is the only field in the select. Don't do select product price, comma, product code. We're matching this field to this field when you're doing this subquery. So it's going to find the highest price for this vendor. Well, actually, what's going to happen is this is going to bring up all the prices for that vendor code. And since we're using all, it says it's got to be greater than the highest out of all of these. Here's the inner query, and it's returning these 3 values. Outer query resulted in nothing. And do you know why? Because that vendor happened to have the highest price item. So there's nothing that's more expensive than $256.99. Here are the any and some keywords. You can use either one. So if we have, well, as long as X is greater than anything in here. So that's greater than, that means take the smallest. Less than, take the largest. Again, you're not going to use it very much for the equal and the not equal to. So I'm going to use the exact same query, but change the all to any. And, well, what's the lowest? $99.87. So as long as the product price for some product is greater than 9987 is going to display. And as you take a look, we've got 4 records that are greater than the 9987. Do you see where the 9987, as long as it's greater than any of these, and those are. So there are 2 variations of subqueries. What we've been looking at are self-contained. So you've seen that I could take the inner query and execute it, see what the result sets are, independently of the outer query. There is also a correlated subquery. And with a correlated subquery, there is a reference in the subquery to the table that's in the outer query. This makes the subquery not independent. What happens is it's going to logically evaluate each row one at a time. It's going to take the first value in the outer query and run the inner query with that value. Go out to the next value in the outer query, run the inner query. The author gives us an analogy of a nested loop. So if you've written nested for loops, a correlated subquery is similar to that. Here is a query with a correlated subquery. Well, what makes it correlated? It looks pretty similar. We've got a where clause with a subquery in it. But notice that the invoice here has an alias, and that alias for that invoice is used inside the subquery. This is what makes this like an inner loop, because it's going to grab the first customer code and join that with invoice. Then it's going to take the second customer code and repeat it. What it's actually doing is this is actually averaging the invoice total by customer. And I did a query real fast, and these are the customers with invoices. Some have multiple invoices. It got the average of those invoices. It took the average of those invoices, 1827, and it says, well, if we're going to display these values if the invoice total is greater than 1827. Is there an invoice total greater than 1827 for this customer? And there was, and that's what displays. This is what result the outer query will show. Goes to this one, and average is 93.89, and evidently there's not an invoice greater than that. And to be honest, there's only one record, so there's nothing greater than the average. If I change this to greater than or equal to, you will see that record displayed. This customer had multiple invoices. Here's the average and the highest of those multiple invoices displayed. These other 2 customers just, again, had one record. Correlated subqueries can also use the exist keyword, and the syntax for this is where not is optional, exists, and then a subquery. Here is an example I've gotten from Geek Engine that has an exist. So we have where exists. The subquery is just pulling records. Notice I don't need to match columns when I had exists. It's saying, is there a record for this certain customer? Notice it is a correlated subquery because the C here is used here. For that customer, do they have an order record that's shipped from the UK? That's what this says. Is there an order record for the first customer that shipped from the UK? Yes, display it. No, don't display it. Go to the next customer, repeat. So do you see how that's an inner loop? In the outer part of the loop, we'll pick one customer, and then it's going to go through every record and see, is there a matching customer in order that's shipped from the UK? The 2 things I wanted to point out, when you're using any or when you're using all, and usually when you're using the where clause to do a join, you want to make sure that the field here and the field here, at least the same data type. Usually they should be the same field, maybe in different tables, but at least the same data type or will not work. But when you use the exist, Notice all we care is true or false. Did a record return for that customer? True? Well, since this exists, if it's true, we'll print it out. Well, here's not exists. So if a record does not return, then it displays. We want to know who didn't get anything from UK. Here is another example. And this is another way, this is like the third way we figured out how to find out who does not have an invoice. So this selects anyone that has an invoice. Notice it's correlated because this is making a reference to that table in the from clause. Here's from invoice, so that's in the subquery. Correlated. Using the asterisk here, it says not exists. Oh, okay. So there's no invoice for this customer. I'm going to print that customer code out. Another place you might put a subquery is in the from clause. What does the from clause want? The from clause wants a table. So notice this is just producing a derived table is what it's called when you put it in the from clause. All invoices, I want the customer code for all invoices if it's greater than 25. Alias that as invoice 25. So that's as if it were a table. This is not a correlated subquery. Okay, this is just a subquery written in the from clause. And then that's as if it were a table. Let's match it up. Here's your first table. Here's your second table. And here's the on. And this is the result set. Returns this. And that's the result set. So here is a select. Now in the select clause, it's going to return exactly one value, the highest invoice date. Now, it's a correlated subquery. So for each customer, it's finding the largest invoice date, the most recent invoice date in that table. Customer here inside the subquery, meaning it's correlated. Now notice it did return nulls for those that did not have a matching invoice and like an outer join. So here is just an example of using 3 subqueries within a query. One's called top of state, one's called summary 1 and summary 2. So it does look very complex, but if you break it up, it's doable. Here's the steps that are recommended. First, solve it in English and write our pseudocode. Outline each subquery in the pseudocode. And then if they're not correlated subqueries, code each subquery and test them individually. And then finally pull it all together. So that covers subqueries. Have fun writing your SQL.